Recent figures indicate that there are more than 200 million insects for each human on the planet. How does insects multiply? Let's explore the reproductive system. The reproductive organs of insects are similar in structure and function to those of vertebrates. A male's testes produce sperm and a female's ovaries produce eggs. Both types of gametes are haploid and unicellular, but eggs are usually much larger in volume than sperm. Most insect species are bisexual and biparental, meaning that one egg from a female and one sperm from a male fuse to produce a diploid zygote. There are, however, some species that are able to produce biparthenogenesis, a form of asexual reproduction in which new individuals develop from an unfertilized egg. Sexual reproduction might well be the most important adaptation ever acquired by living organisms. It provides a mechanism for shuffling and recombining genetic information from two parents to create new genotypes that can be tested in the fire of natural selection. Like humans, most insects have a single pair of chromosomes that carry the genetic information for determining an individual's gender. If an embryo inherits a pair of X chromosomes, it will develop as a female. If it inherits one X and one Y, it will develop as a male. The XX female is said to be homogametic. The XY male is heterogametic. In this case, the male's contribution determines the offspring's gender. In Lepidoptera and Trichoptera, females are heterogametic and males are homogametic. To distinguish this system from standard XY sex determination, these sex chromosomes are designated W and Z. Thus, a female butterfly is W and Z, and a male butterfly is W and W. In this case, the female's contribution determines the offspring's gender. Haplodiploidy is found in Hymenoptera, many Thysanoptera, some scale insects, and a few weevils. These insects have diploid, homogametic females, but all of the males are haploid. They develop by parthenogenesis from unfertilized egg. Control over gender of offspring has proven to be a useful adaptation for some insects. A biased sex ratio that favors females over males can reduce competition for limited food resources and increase the reproductive potential of the population. Bees, wasps, and ants form large colonies of queens and workers in which males are produced only sporadically as needed for reproduction. The female's reproductive system contains a pair of ovaries that swell with developing eggs and may nearly fill the abdomen. Eggs are produced in the ovarioles. A typical ovary may contain dozens of ovarioles. Mature eggs leave the ovaries through short lateral oviducts. Near the midline of the body, these lateral oviducts join to form a common oviduct, which opens in a genital chamber called the bursa copulatrix. Female accessory glands supply lubricants for the reproductive system and secrete a protein-rich eggshell that surrounds the entire egg. During copulation, the male deposits his spermatophore in the bursa copulatrix. Peristaltic contractions force the spermatophore into the female's spermatheca, a pouch-like chamber reserved for storage of sperm. Its spermatical gland produces enzymes and nutrients. Sperm may live in the spermatheca for weeks, months, or even years. During ovulation, each egg passes across the opening to the spermatheca and stimulates release of fused sperm onto the egg surface. These sperm swim through the micropyle and gets inside the egg. Fertilization occurs as soon as one sperm nucleus fuses with the egg cell's nucleus. Oviposition usually follows closely after fertilization. Once these processes are complete, the egg is ready to begin embryonic development.
Created using Powtoon.